All right, give everybody a second to join here. Thanks for joining, everybody. Just waiting for the room to level off here. All right, I'll get started with intros here. Thanks for joining Module 4 of our Electric School Bus Familiarization webinar series. This is Charging Overview. Let's go to the next slide. Okay, just a couple of housekeeping notes up front. Controls are located at the bottom of your screen, and we will be taking questions after each presentation, so please submit them via the Q&A button at the bottom there. Next slide. We are recording this webinar and it will be posted, so if you speak or use video, you are presumed to consent to recording and use of your voice or image. Next slide. And the Joint Office mission is to accelerate an electrified transportation system that is affordable, convenient, equitable, reliable, and safe. And our vision is a future where everyone can ride and drive electric. Next slide. So the Joint Office does support several programs that were established in the Bipartisan Infrastructure Law, which you can see here. And that does include the Clean School Bus program, which distributes $5 billion in support of electric school bus deployments. Next slide. So to support the EPA's Clean School Bus program, the Joint Office has partnered with EPA and the Department of Energy to provide free technical assistance to school districts that are currently receiving EPA funds or are planning to apply for future rounds of funding. And our goal here is to provide school districts with the knowledge, tools, and information needed to successfully plan for and deploy clean school buses. Eligible entities can request assistance by filling out the online contact form at driveelectric.gov. That's also where this QR code goes. And then you're also welcome to email us at cleanschoolbusta@nrel.gov. Next slide. So here's just a few examples of how we can help. Inquiries are not limited to these topics. Please contact us on anything from simple questions to complex, in-depth assistance. We're also available to discuss or review your ideas or plans, or just be a sounding board along the electrification process. Again, we provide this service free of charge. There are no strings attached. You contact us once, and that be it, or it can be, some long-term meetings that we have. Happy to do whatever any school districts need. Next slide. If you're here, you know this is our electric school bus familiarization webinar series. We have presented 4 modules on the fundamentals of ESB technology. We will be producing testing materials for all of these modules, the completion of the series today, and then publishing them online so that school bus fleets can incorporate the recordings and the test materials into their internal training programs. So if you've watched the entire series, thanks for joining for the last one here. If you did miss any of the recordings, they are up on driveelectric.gov at this point. Next slide. So today we have 3 great presentations for you, and we will have Q&A after each of the presentations, so please submit your questions. First up, we have Brad Beauchamp from Bluebird Corporation with an overview of charging and technology. Then we will have Stephen Kelly from InCharge with facility operations and considerations for ESBs. And then third, we have Richie Beebe from OWL Services covering charging standards, maintenance, and safety. Next slide. And then today's moderator will be John Chavone. John has been involved with transit bus maintenance and technology for nearly 40 years. He served on the APTA staff, authored several Transportation Research Board studies, and is now working with the Center to Advance Frontline Worker Training and Apprenticeships. So over to you, John.
Thanks, Ryan. I'd like to add my welcome to you all for attending. Next slide. At the International Transportation Learning Center, our mission is to advance training on a joint labor management basis. We feel that training is more effective if both labor management work together to produce that training and have a say in how it's developed. We've organized a similar webinar for transit buses, and is why we were asked to do the same for the electric school buses. And the purpose here is to provide introductory information. You're not expected to be able to work on these vehicles after listening to this, but you should have a good foundational background information. Next slide. Here are some of the key terms that we've used throughout the 4 modules. Ones in particular that we'll be looking at today: AC and DC. Electric school buses use both alternating current and direct current. We'll be looking at V2G, vehicle to grid, and also V2B, which is vehicle to building, which is not included here. But everyone on this call will get a copy of the presentation, so there's no real need to take notes. Next slide. So as Ryan said, we've had 3 modules previous to this one, and up the upper right, you'll see a link to each one of those where you will get the entire presentation. It's difficult to summarize each one in one sentence, but I'll go ahead and do it anyway. In Module 1, we looked, it was primarily directed towards the operator and what he or she needs to know to operate and drive these vehicles. And the bottom line is the operator plays a major role in extending battery life and range. The way you apply the accelerator and the brake play a big role in that. And Module 2 was provided a technology overview. And from that, the most important thing to know is that there's direct current. The batteries are DC, but at a very high voltage, and it's converted to AC or alternating current to power the traction motor and the wheels. And in Module 3, we looked at high voltage safety considerations. And from that, the high voltage requires specialized training, tools, and equipment to remain safe. This isn't something you're going to pick up on the shop floor. You really need, because of the high voltage and the safety implications, it's safe if you know what you're doing, but you first have to know what you're doing. So the training becomes very, very important. And if you do not have a good understanding of basic electrical, you will need to first acquire that as an essential prereq. Next slide. And with that, I'll turn it over to Brad Beauchamp. And remember, encourage you to ask questions as the presentation is going along, and we will address those questions at the end of Brad's presentation. So Brad, take it away.
Thank you, John and Ryan, for queuing this up. So charging overview and technology. We've got over 2,000 deployed so far, so we've got quite a bit of experience, and there's a wide variety out there. So let's start into what we consider for charging the electric school bus. Roll me forward. All right. So the first thing is the learning objectives here are really to describe the considerations for even getting started. Right. You got to start somewhere. Examining the options that are out there. Looking at the basic terminology and components. AC versus DC charging has been brought up already. What is it, right? And charging times, super important to kind of understand how long it's going to take that bus to come back up to being fully charged. And then just, again, the components that are involved to be able to get that charger to work, the transformer, switchgear, and even service disconnects right at the charger itself. So let's start down that journey. Roll me forward. So basically, through the electric school bus program and some of the other state funding sources and local and utility funding sources, it's facilitated over 12,000 school buses to be deployed over a 5-year period. roughly 35 to 4,500 of those will be out running routes and actually are executing that today. Again, we got over 2,000 out there today already. School bus is roughly a 40,000 volume per year market, so you can kind of size it up. It's running around that, 5, 6, 7, 8, 9%. There's 500,000 opportunities. There are both Type C, Type D, and Type A. We're going to concentrate on Type C and D school buses here today for charging, but Type A charging isn't really all that dramatically different. And obviously, challenges are there continues to be a driver shortage, and that's not an EV thing. That's an all-around school bus thing. So roll me forward. So charging is really filling the fuel tank on that bus. It's the energy, whether energy is through diesel fuel, natural gas, propane, gasoline. In this case, it's electrons going in from the actual power grid. A battery itself typically today is lithium based, so it's called a lithium ion battery. There's some emerging technologies coming, but primarily today there's NMC and LFP that are the two that are powering transportation. Both are very good for transportation. They all have the same basic components, a cathode and anode, some electrolyte material in them. They just have different chemistry composition. So you're basically putting that energy from the grid into chemical energy stored in the battery. Roll me forward. As I had mentioned, there are charge times involved, and whether it's a Type C or D, this is where the similarities are there in Type A. Typically, on AC charging, you're going to have 3 to 8 hours of charge time to bring a bus that's returned to the yard back up to full state of charge. And it's mostly done overnight right now, although you could opportunity charge during the day. It's mostly overnight. But regardless of the bus, AC charging is going to take about that long. DC fast charging is going to speed that, get it closer to the 3-hour time range. In some cases, even a little bit better than that. These buses typically have somewhere between 100 kilowatt of usable capacity and a little over 300 plus kilowatt hour capacity in the battery. So there's battery options. And they're designed around ranges for school bus to be around 100 to 150 miles a day. Now, that 100 to 150 miles a day, you still want to roll forward into roll in with still some range left, so that as you charge the bus, you're not completely depleted. Capacities on a Type C bus up to 77, Type D's up to 84, so a little more capacity. And similar, gross vehicle weight ratings on the C and the D to what you'd find on a conventional internal combustion engine bus. Propulsion system, instead of having that internal combustion engine, is going to have a mix of pumps, compressors, motors, typically a similar in horsepower motor to what you're used to with a gasoline, a propane, or a diesel power, 300 plus horsepower out of the electric motor. And because many of these buses, including ours, don't have a transmission behind them, they have some really large torque ratings because they're actually using that motor to get the bus up to speed with a single speed directly connected from the motor to the axle. And in most cases for pre-trip, the things that you do on the electric school bus are very similar to what you do on a gas or diesel bus, from a steering, suspension, braking, all the safety items that are on the bus. So roll me forward. When it gets into charging, some things that AC and DC fast charging need to take into consideration is the draw on the bus as it's being used and also just as it's charging. So things like heaters that defog or defrost the windows in the bus, the heater itself that keeps the battery warm, chiller, if it's the warm weather, that'll chill the battery. If you have AC on the bus, you'll also potentially have to use some energy to do that work. That'll take away from range. And then there's things like an air compressor and a power steering pump that are also electrically operated. Each of these has a nominal kilowatt value. Don't get too caught up in that. But what you should think about when you're charging is some of this stuff, like heating the cabin and defrosting the windows, or chilling the cabin with air conditioning, conditioning the battery so it's ready to go. That can actually be done while the bus is hooked to the charger. You're going to want to consider sizing that charger, and there'll be others throughout this module that'll help you with that, but you want to consider sizing the charger to meet those needs. The buses do come with regenerative braking, which means that the energy from the bus as it's slowing down isn't just turned into friction into heat. It actually puts energy from the motor back into the battery pack, which then again gives you additional range from regeneration. As John had mentioned, driver habits are huge in that, capturing regenerative braking and the ease acceleration. But things like terrain, wind, temperature, ambient temperature, city versus rural, and even the estimator on the actual bus itself to tell you how much range is left, certainly important for the driver to understand, as well as the entity that's overseeing how the bus is going to be charged, because they all have an effect on it. Roll me forward. So batteries themselves, whether it's 10 degrees below zero or 110 degrees out, they're going to take some time to charge. They like to be, like we humans do, between 60 and 85 degrees. Optimally, 68 to 80 is their happy range. And the thermal management system takes care of all that. But as you're sizing the charging apparatus, you want to look at your climate and decide, what may I need to consider. And we'll talk about it here in this part of the presentation in a minute, as things that'll need to happen before the battery will start to take a full charge at its quickest. But temperature is a consideration. Roll me forward. So good, better, best strategy in starting out, right? Obviously, if you're getting a wave of buses and it's 1 to 5, the starting point could be simple, single phase power, 240 volt AC charging. That ranges for manufacturers that are from 10 kilowatt all the way up to 19.2 kilowatt, which is typically a 48 amp to an 80 amp single phase 240 volt circuit. Installation can often be done in your yard with existing power. Oftentimes, you might have that power available in a convenient spot where buses already park. It's low cost to get started, and again, good for overnight charging scenarios. Better, DC fast charge is always better. And if you have more than 5 buses, you're probably, even with AC charging, going to want to make considerations for DC fast charge for those times when you need to put charge in that bus a little bit quicker. And if for some reason you have a charge cycle overnight that doesn't take place, you can have a chance to recover, and or for other routes and trips that you may need. It's better. They typically run from 20 to 60 kilowatt. The buses usually top out somewhere in that 60 to 80 kilowatt ranges that are max input. So, usually something in that 60 kilowatt range is considered to be on a DC fast charge, certainly adequate. Often has the potential then to charge the bus from empty to full in less than a couple hours. And you may have, again, 1 for every 5 to 6 buses. This allows you also in very, very extreme climates, one way or the other, to do some preconditioning on the battery in the bus, as I talked about previously with these DC fast chargers. Does not mean you can't do it with AC charging. It just means you have to understand your conditions to optimize for it. Best would obviously be doing a full-scale yard project. There's not many that are commonly possible or out there today. And that's when you do a phased-in project to put the best of all hardware, routing of lines, your utility bringing in the optimal power. Yeah, that's great if you get the funding or have the ability to fund a project like that. But certainly good and better will help you get things started. Roll me forward. So you need to plan, when you're going to charge, how you're going to charge, certainly what sort of power requirements the utility might need to bring to you, and early on get your utility involved in that conversation. Then you're going to want to fit your chargers to your particular facility design. Even parking the buses, the direction you're going to park them and how you're going to park them makes difference. Most cases the charge ports are available in the rear of the bus, the front of the bus, and some of us have an option to do either one of those. But you want to think about where that bus is going to be parked and how that driver and or maintenance crew is going to be able to take the charge cord and plug it into the bus. What type of communication are you going to need from the charger itself, maybe from the bus and the charger? You got to understand what that means, and sometimes what's involved for Wi-Fi capabilities or cellular capabilities. And then what type of cost to charge the bus? Talk to your utility about rates that are available. That'll also help you make decisions on how to size your equipment. And then certainly depot charging and standalone are available. There are districts that actually do take their buses home. We have worked with districts that have take-home buses, and you can certainly charge a bus as a take-home as well. It just, again, takes talking to your utility and thinking through things like demand charges and, peak tariffs and what kind of load you can actually manage from the site that you're on. So roll me forward. Electric school buses are a great use of EV technology in general because they have long dwell time. They typically sit, long periods of time, so have the chance to charge at lower levels. Uh, Operators are finding that charge management software is helping them even get more efficient. Interconnectivity to be able to basically see all the elements, right? See the charger, see the bus, look at what level they're at. Even look at things like over-the-air updates for the systems should they need maintenance that's done. Sometimes it can be done remotely. Then it's considering when you get better things like cost and demand charges so you can optimize further. The thing I'll tell you with all this is you want to think about it, but don't get too bogged down in getting started. You can, in a lot of cases, as long as you've thought about it and stated that you want to think about it over the long haul, you can definitely optimize, get started and optimize. And as I mentioned, all these buses that we build today are back to grid capable, and that's starting to be something that people are considering, the bi-directional chargers. So roll me forward. Charging as a service is also out there, and I know it's going to be covered later, but it's a way for you to actually put charging in your yard and having somebody else manage that for you. That means that the typical maintenance staff, your buildings staff, or the transportation department doesn't necessarily have to think about that. They'll have somebody come in, and you have levels of service that can accommodate getting you started. Now, does that mean you do that forever? Maybe it does, maybe it doesn't, but sometimes it's good for charging as a service just to get you started. It has some advantages even as the upgrades come into place. And again, that'll be alluded to in another presentation in more detail and depth. Roll me forward. Simply charging, you've got your high voltage power supply or transmission lines coming in. They then will actually go through some sort of charger itself. If it's a DC charger, it's taking the AC current. AC is the common current that comes into your building and turning it into DC at the charger level and then doing DC fast charge between the charger and the bus. So AC is turned into DC at the charger and then DC is charged the bus. Very efficient, very direct and straightforward. In the case of using that AC power with level 2 charging, the actual charger converter to take it from AC into DC is actually on the bus itself. So it'll be a module on the bus. It's then taking the AC current directly from the grid. The bus is then changing it to DC and charging the battery in the bus. Both are great options. And again, they need to be thought through and at least understanding what they are when you're making your decisions. Roll me forward. Some common things you'll hear when you talk to your utility. Obviously, as I mentioned, AC alternating current. That just means that at 60 cycles per second, we're flip-flopping the AC and DC. That allows us to transmit high voltage over long distances. DC or direct current is when you're taking a positive, negative, and applying it directly to a storage source, such as a battery, or to a load, such as a motor. DC is what the batteries charge with and store energy at. You'll hear about the kilowatt. That's the actual 1,000 watts used in an hour is considered a kilowatt hour. And a kilowatt itself is considered to be 1,000 watts. It's really your, I'll call it your gallons per minute, both pressure and flow of delivery of energy, just like a hose delivers for fuel into a vehicle. And the kilowatt hour is kind of like your storage per gallon, right? How many gallons can I store is how many kilowatt hours of energy can I store in a battery pack. So you hear it expressed that way. And then the bus is going to use energy as it goes down the road. And in the vehicle arena for EV vehicles, it's usually how many miles I can consume per kilowatt. In a heavy bus, it's how many kilowatts are consumed per mile. Today, that's around 1 kilowatt per mile to sometimes up to 1.4. All right, and then you have an amp and a volt. Again, amperage is kind of like the actual flow itself, and the voltage itself is the amount of flow, so pressure. So flow, amperage, pressure is voltage. If you take amperage times voltage, it equals wattage, and obviously 1,000 watts, as I mentioned, is kilowatt, and then the storage capacity is a kilowatt hour. So you'll hear those terms commonly: amperage, volt, kilowatt, kilowatt hour. Roll me forward. All right, so on the vehicle itself, you're going to have a battery management system where it actually manages the flow into that battery. So you'll hear that referenced. It's actually the one that controls flow of energy in and out of that battery pack. It decides where that energy, the amount of energy is going to go in. The pack itself has some internal communication to monitor cell temperatures and levels, and basically guides energy where it needs to go to give the most efficient charge. There are systems on the vehicle that are run at different DC voltages, like your actual accessories, the lighting and radios and camera systems are often off a 12-volt DC, and the bus is a 650-volt DC vehicle. So they'll have various converters, sometimes called buck boosters, that also will raise and or lower voltage to be able to meet the requirements on the DC side. Again, for AC to DC, it's called a converter, and then you actually sometimes take DC and create AC off of it to, let's say, propel a drive motor or operate a power steering pump. The chiller itself, they may be AC motors that do that work. So there's DC to AC inverters. So all these things help on the bus itself take that electric energy and allow the components and the bus itself to operate. And the charger is the one responsible for delivering that energy to the battery.
Hey, Brad, it's John. You have 5 minutes.
All right, roll me forward. All right, and EVSE is just a simple term for the charger itself. You'll see HMI, which is how you interface buttons and screens. You'll have a charge cord, whether it's a simple AC charger like you show on the left or a DC fast charger in a larger level on the right in the screen. And that charge cord then connects to the vehicle. Both AC and DC chargers have similar interface, and it's known as a J1772 CCS1 connector to the vehicle. That's the most common type used today, and that'll be expanded upon a post. Roll me forward. So AC charging and DC charging that we covered before, again, they're basically the same method of getting that battery charged. One, the charger's doing that DC conversion, the other one, the vehicle's doing the DC conversion. So level 2 is usually AC, DC fast charge is usually DC on the charger side. All right, roll me forward. So again, AC charging is going to be lower level, DC higher level. So roll me forward. The charger itself can be a simple, what's called a dumb charger, which is simply checks to the vehicle to make sure the vehicle's ready and the vehicle communication is set up for the vehicle to deliver energy. These are examples of a DC fast charger and AC where they really don't have any software over the top of them. They're just using that to actually charge the vehicle. These are great for doing maintenance work to determine whether a charger or vehicle is an issue. And some of them can even be portable for shop applications. Roll me forward. Smart charging, that's when you get into having software over, and that's going to be talked about further too, so you can roll me forward onto this one. Again, we're using AC charging or the combo charger. Both of them incorporate that AC J1772. The difference is when you go to DC fast charge, it has the combo charger where the 2 pins for DC fast charge are incorporated into the actual plug itself. Roll me forward. Forward. All right. Mostly AC is going to be for applications where you're putting 40 miles of range in a vehicle, often in I'll call it a 5-6 hour period of time. If you want to fully charge that vehicle, it's going to be overnight. DC fast charge is for those applications where the vehicle is doing 40 miles per. There is some crossover here depending upon temperature, but these are the typical that are found for school buses. Roll me forward. There are chargers then to look at. Even in AC charging, I talked about 240 volt AC. Those same chargers often operate on a 208 volt, which is part of a 3-phase system. The difference is there's charts and times that accommodate, and the amount of actual rate of time to put 100 kilowatts in a battery is displayed here. So 100 kilowatt hour battery, and this is giving you your relative charge times. Just need to be familiar with that as you're planning your actual charging. One, for how long it's going to take. If it's overnight, it's usually not a challenge. If you got to take note of demand charges, then you might have to consider alternate methods here. But there's chargers for every level here. Roll me forward. And again, cold weather. Not that you can't charge in cold weather, but there's going to be some time just to heat that battery in cold environments. So that gets added on to the total charge time. Again, we can help you with calculations both on the charger side and the vehicle side, what's expected, and that you don't end up with a charge time. Typically, more than 14 hours is a challenge, right? So you want to have that charge time overnight being less than that. Roll me forward. That's it. Roll me forward. Transformers and switchgear. Simply put, you're going to have a transformer. It's going to supply either single phase or three-phase power. It steps it down to the level the charger needs. The switchgear is what controls the load between chargers. So it's going to send that charger somewhere automated, somewhere manual. And then the service disconnect is actually at the charger itself to allow you to turn power off for maintenance work or replacing of the charger itself. So pretty simple and straightforward, but you'll hear that from your installer and sometimes from your utility. Roll forward. And I'm going to let this AC charger recommendation go with the in-charge charging folks. So roll me forward through this because there's both AC and charge that's available. A lot of it depends upon what your utility can provide as to what you get started with. And roll me forward. And that completes the section on what to think about. So thank you for that.
No, thank you, Brad. That was well done. Very thorough. We have several questions here. I'm going to start with the questions that we received in advance. And the first one is, who are the leading charging station vendors, Brad?
Yeah, so on the 2,000 plus vehicles we built, we're charger agnostic. We do have within Charge, that's actually part of this presentation set today, a preferred provider agreement because they've done a lot of school bus work in general. So we know that but certainly any J1772 CCS1 connector, usually from 10 kilowatts on up, or DC fast charge. Again, we cap out somewhere in the 60 to 80 kilowatt range, depending upon the battery you picked, is certainly compatible with the vehicle. To help you, if you have questions about that, make sure that we've done the interoperability testing if it's something we hadn't done before. But we do spend a fair amount of time making sure that vehicles are interoperable, whether it's charging or VDX. So we are charger agnostic, CCS1, J1772 being the guiding standard.
Okay, thanks. Here's a question we all want the answer to, but I don't think there is one. How will the change in administration impact funding for e-school bus programs?
Yeah, so generally electric school bus and the EPA funding, we're in round 4 right now of $5 billion. It's needs to be closed out here soon. Like anything, electric school bus is a great application for EV, and kind of bipartisan has support for school bus. EV in general may have some controversy, but school bus, it's a no-brainer. So we will keep tracking forward, and we know in the school bus arena, the investment that's been made over the past 6-7 years in the Bluebird arena and others is going to continue forward. So we certainly intend on providing electric school buses as federal as we have options for you to consider as well. There's options like Clean School Bus that can help you, funding or no funding, get this accomplished. So kind of, I'll say, risk aversing or taking risk out of it for regardless of what the incentive environment is.
All right, good answer. Are any buses in the U.S. using MCS, or are they still CCS1? And how do we avoid repeating the CCS1 / J3400 problem?
Yeah, so great question. As the NACS and J3400 starts to be more commonplace over the next 2 to 5 years in the retail arena, today there's adapters available, right? You can use your CCS1, depending upon your vehicle manufacturer, on the J3400 standard. So the buses are already, being put that in scope, but they're going to come, as all commercial vehicles are currently, with the regular J1772 CCS1 protocol, which again, while we forward thinking, if we need to move to that J3400 standard, the commercial truck arena is moving much slower toward that. Very different from what the retail needs are. Doesn't mean it couldn't be done. It doesn't mean it can't be done because it's actually I've been able to use the adapter successfully on our vehicle. With that said, we're staying with 1772 CCS1 in large part.
Right. Are electric school bus manufacturers considering heat pumps for cabin heating instead of resistance heating or fuel burning heaters?
Yep,
Because
it's a
those,
great question as well. And there are some heat pumps starting to come into the marketplace. Certainly, we had air conditioning on today, and a heat pump's no different than that air conditioning system running in reverse. That would definitely make a bus for heating side more efficient. It adds some cost to it, but we are studying it, and I would expect that there will be some call for that in the coming years. Currently, we do add fuel-fired heaters if that's allowed under the grant program or if you need them. About 2% of what we build actually has a fuel-fired heater on it today. If not, then the resistance heaters are continually being improved as well as the systems to help as well. But we expect heat pumps to come into the equation here as well.
and will overnight charging maintain a charge on the 12-volt batteries as well?
So another great question, and it depends upon the bus manufacturer, but when the charger is hooked up, if you look at in the case of our bus, you will see that the 12.6 or 12.5 volts that are showing when the battery's sitting without energy going into it while you're hooked to the charger will go up in voltage. Typically 14.2, 14.3 is what you'll show. So the answer is when the charger's hooked up, it is charging the 12-volt battery. Some past iterations, not only with our product, but with others, we did not have that engineered in and would often have, if you shut off the 12-volt battery, then it's not receiving charge. So a vehicle can charge with the 12-volt disconnect shut off if it's initiated. So you got to be aware of that because then your 12-volt is not receiving energy from the system typically when that happens. But yeah, the 12-volt would be charging when connected to a charger.
Is there an option to do both AC or DC charging?
Great question. And yes, with the small exception of a small number of batteries that we have available, and we would alert you at spec that are DC fast charge only. Most everybody, while there's some DC fast charge manufactured buses out there, most everybody is moving back to that AC as well as DC. So in our case, we went shortly to DC only, but we had the AC available at all times, and we're sticking with both of those options because they're both important for school bus.
We have some great questions remaining here. I'm just going to take one more so I don't impinge on the other speakers, and we have time later in the program. We'll come back to them. But did I hear correctly? Use average is 1 kilowatt per mile?
That's correct. It's consuming a kilowatt hour of energy for every mile traveled. If you're running full accessories, including heat, you can do that calculation off of 1.4 kilowatt hours being consumed per mile. There are some rare cases where it does go in excess of that in extremely cold weather, but that's typically not student transportation weather. So so the vehicle is using a lot of kilowatt hour capacity from that battery as it's being used in service.
Okay, well, Brad, thank you for that presentation. That was very good. The answers to those
Thank you,
questions were
John.
great. And the people who submitted the questions, great. And I hopefully we'll get to the rest of them. But let's go to the next slide, and I'll introduce Stephen Kelly with In Charge. And with that, he will give us a presentation on facility operations and considerations for ESPs. Go ahead, Steve.
Thanks, John. And Brad, great overview of a number of the things that are happening in the industry around school buses. So why don't we move to the next slide, and I'll give you a little insight as to what we want to cover today. So a couple of the key features that I'd like to highlight is one, really helping you better understand the planning and the power requirements associated with putting electric vehicle infrastructure in your facility. There's quite a few things you need to do and understand in order to do that correctly. A lot of this is around the vehicle you're getting, the design of it, the location, the available power that you have, and then the dwell times when they come in, when they go back out, and your utility tariff. So my job today is really to help you better understand some of those challenges, how to address them, and how to make sure you've got a great project. In addition to that, you want to understand once you have the infrastructure installed, how are you optimizing the charger to be able to, or the charging times to be able to get the lowest cost to charge your vehicle in the fleet. So I'll talk a little bit about load management and the ways in which you can optimize that to be able to reduce your total electric bill, reduce demand charges, and then really go into what those ROIs look like. So we'll go to the next slide. And so how does this whole process really happen? So to me, one of the most critical steps is really to figure out the planning piece of your infrastructure. So as you start down this journey or you add on to additional vehicles in your fleet, I think the key is really figuring out where do we want to put what is the optimal place to put the vehicles? What is the optimal size charger to use? When should you be charging? Do you want to do V to X or not V to X? And those, all of those discussions are critical in making sure you've got an infrastructure that works today, but also in the future. You also have to look at your facility. There's very few lots I get to go out to where they have loads and loads of space and you can put them anywhere. Most of them are very constrained, very tight. They have limited power. And so, really understanding the operational flow of your facilities, do you pull in, do you back in, where to put them, how do they move around, is critical in putting in your charging infrastructure. Um, Interoperability is another thing that I want to talk to you about because not all chargers work with all buses. And so, really making sure you've got that covered is a critical piece. I think I talked a little bit about the managed charging, which we'll go into more detail, and what those costs and rate structures are. So, let's go into the next slide and get into this. So, in the planning piece, it really does start off with just basic information. What is the vehicle you're buying? When do they come in? When do they go out? How many miles do they drive? Are they going up hills? Is it a cold weather environment? All of those impact the mile to kilowatt hour conversion rate. But you want to go beyond that. You want to look at cord lengths. I I was with the school district about a month and a half ago, and they called me up and said, "Hey, we just installed your chargers. It's great, but they don't fit." And I'm like, "What are you talking about?" And they never had looked at the distance between the charging port and the vehicle and where they put the charger. So these are some little things that you want to make sure as part of a plan that you factor in so that you don't have to deal with it after the fact. So getting a good partner that can help you not only understand what is the right charger, where to put it, where and how long of a cable do you have, how do you handle cord management, and when you should charge is critical in having a successful project. We're going to go to the next slide. So what are those key steps and how do you address each one of them? So on the fleet side is you want to know what is the maximum charge rate of the vehicle, what is the mile to kilowatt hour conversion rate, and you probably won't know that. So that's a factor in partnering with both your OEM partner as well as your installation partner to make sure that that is true for your environment. There's also this issue called thermal load management. I've seen a number of customers that have said, "Oh, I can just use a low end, level 2 charger to charge my bus," and only to find out that it doesn't work because they've done the math wrong. So I'm going to help you understand that a little bit in the example coming up, but also then understanding what is the voltage of your vehicle. There are some older chargers, if you were early in installing electric vehicles, buses, that were operating at 400-volt architectures. So you were able to install chargers that were at the 500-volt architecture range. Well, if you're buying a new vehicle that's now in the 600 or 700 range, it doesn't work with that charger. So making sure that you've got the right charger for the vehicles is key. The other thing we look at is, what is, like I mentioned, the dwell times, the drive time, the operational flow, and making sure that's all built into your plan. Once you collect all that data, we'd like to go on site and really look at what is there. Do we have enough power on site available in the current capacity of the panel to be able to support the number of vehicles that you have? Do we need to do utility upgrade? Do you only have, 480 power or 240 power? All of these things can help impact with the decision on what charger do you want to install and where do you want to put it. It's really around helping you understand where's the optimal charger, where's the optimal place to put it, and then how do you future proof for additional vehicles down the road. And the last key thing that I really want to emphasize is partnering with your utility. Take this plan to them, help them understand what you'll be doing over the next few years, so that if you do need a utility upgrade, they're aware of it, they can start planning for it, they can start working within their own capacity planning. So you're not waiting 2 years to get an infrastructure to be able to power your vehicles. So those are some of the key areas that we recommend focusing on the planning side of your developing your project and making sure you've got the right information to be successful. Let's go to the next slide. So when I mentioned about the thermal load management, that when you're using a level 2 charger in a bus, not all 19.2 kilowatts go straight to the battery. because the vehicle, as you're charging, needs to keep certain onboard functions working. So you have battery conditioning. If you're a really cold environment, you have thermal loads that you may have to manage. Those all pull power. And some of the most extreme situations that we've seen, that this can pull almost 11 or more kilowatts that is being used by the vehicle and not going into the battery. So this level of analysis and understanding the vehicle and what it actually uses in thermal load is critical, because it can extend your charge times by 2 to almost 3 times with that charger. So this, unfortunately, is where I've seen a few examples where schools had thought level 2 charging would work because they just did the basic math of 19.2 divided by the kilowatt hour rate to figure out what is the right number of hours to charge, and they were off by, a factor of 2. And so making sure you understand this, you've calculated that into your analysis, is a key component if you're going to be using your charger. Going to the next one is, when we also look at the design principles here, is that, what is the right cable location? It still amazes me that this is an issue that we see in the industry, where as they start looking at the cable lengths, they basically, let's say you have a 16-foot cable, and they measure from the charger to the port, and they say, oh, it's 16 feet, it'll work fine. Well, it won't work fine, because there is, as it comes out of the charger, there's a bend. As it goes back over to the charging cable, there's a bend, and it goes in. So you really need something closer to that 12 to 13-foot distance to be able to make that work. So we've done a mapping with all of the OEMs that we work with to make sure we understand what is the right charger length. Can we use a charger with 2 cords? And many times we install one side with the 25-foot cable, the other with the 16, and then we can charge 2 vehicles with a single charger using the different cable lengths to be able to make that work. The other real challenge is civil and construction. When we go on site, we want to make sure, are we hitting underground utilities? Is it easy to be able to navigate? And closer to the electrical panel is critical in lowering the cost and placement of those so they fit. Sometimes we have to restripe and redesign the yard depending upon what they currently have and where to put the chargers. But this is a real critical thing to look at and make sure that you have a good, solid design on where to put the charger, how to lower the cost of installation, and that the cords fit the style that you have for the bus. And whether you're pulling it or backing in, that's another key thing. One other principle here that we've seen, especially in the colder climates, is snow. So designing a system where you're going to need a snow plow to come through there and clean the area is another factor to consider. Let's go to the next slide. So many times when we are starting to roll out, 5 or more buses, and sometimes it's higher than that, but we need to put in a new service. And what this is putting in additional power on site from the utility to be able to power the larger fleet. Typically, a utility will look at, where is the current power coming in, where does the utility want to put the transformer, and then it's the school's choice of, how do I then build my system around that. Each utility is different. They all have various rules. Some will pay for that infrastructure, some won't. But really having a good design of building that in the location is critical. In many cases, we're ramping, not just the initial phase, but phase 2 and 3 of converting to electric, to make sure we've minimized the cost. We've made it a really efficient installation. We're not having to go back out there and install more trenching or cut into the ground in the future. We tend to install a lot of additional conduit for future proofing, so that you can, 1, save cost, but 2, not have to impact the yard in the future. So these are some of the things that we look at when we're installing a new service, or really the on-site work, to make sure that we're in there one time and you're able to leverage that infrastructure in the future. So let's go to the next slide. So this happens to be an example of a school district that we worked with out in Pennsylvania, and they were fortunate enough to get an EPA award for 15 buses a couple of years ago. And when we really looked at their site, their initial design was a real challenge. The layouts weren't very good for where we wanted to put the electric infrastructure. They were trying to figure out their cord lengths, and they came up with a rough design before they got to us that when they presented it to us, our engineering team said, well, this is interesting, but it won't actually work. And so we were able to really help them redevelop and redesign theirs to install a 60 kilowatt system and then 730 kilowatt dual cord systems to support the entire charging of their fleet. Now, you may ask, well, why did they have different chargers? They realized that they had at times a midday charge where the vehicle would come back in the midday, but not have enough time to charge on 30 kilowatt to go back out in the afternoon for one of their routes. So they wanted a faster charger to be able to do that in the midday, but also to use that for some of their afternoon sporting events that were going to go a larger distance, and they could be able to take it out at 4 o'clock and be able to meet the student needs from that. So sometimes you do need higher power charging depending upon the use case that you're using the buses and putting that in. One of the things they really liked about the 30 kilowatt dual cord systems was you could plug both of them in at the same time, and the system would automatically charge one, convert over, charge the additional bus, and they were able to very cost effectively be able to charge the entire fleet. In this particular case, we did have to install a new 800 amp panel. They had 480 on site, which was great. So we were able to go straight DC to DC and add a whole section for future proofing down the road. So what they really liked about this is they could still continue to pull in. We had installed bollards and that we offset those chargers slightly. So even if they had an issue, it wouldn't hit the charger. So you can see some of the installation pictures here. And I think it's just a great example of how a good design helped them solve some critical problems that they would have had if we weren't able to get involved and help them understand that. So let's go to the next one. So we also see a lot of challenges around installations. Some of the schools maybe do not want to install permanent, don't want to trench, or they need it to be flexible to move in the future. So here's a couple of designs that we've done in different locations. You can see the one on the far left, that is a trenchless system. So we go right on top of the asphalt, we install our wiring, we put a cap over it, and it's an extremely fast installation. We do have some sites that we know are challenging with underground utilities or may have some other issues if you start digging. And so that's a great, very fast solution to be able to do that. And you can drive over those at a slower rate. The middle one is a K-rail design. And this happens to be for 36 buses down in Moreno Valley, where you can see they had some existing K-rails and we put our brackets on them and ran right underneath that all the cabling. So the design of this, they knew they were going to modify in about 3 to 4 years. And so we can literally just pick the whole thing up, move it over, redesign the yard, put it back in. If you've got leased property or if you're a contractor, this is a great alternative to be able to have a flexible design and move it around in the future. And the last one over you see here on the right is actually a portable unit. So we do see sometimes where the infrastructure is not installed from the utility quick enough and the buses show up. So we have a whole set of either portable generators, rental units like the one you see here where we just drop off and connect up under temporary power, and you're able to power the fleet. We've also seen a few cases where if you have existing propane, we can connect up a standalone unit. It's literally a unit we drop off in a skid. You can connect it up to your propane, and it's got both battery storage and EV charging, and you're able to get power in a matter of weeks, which is a great option if you have that in your environment. Let's go to the next one. So the last thing I really wanted to talk about today is compatibility. Having a charger that has been tested with your bus is a critical component. I wish I could say that we were advanced enough in the industry that every single charger worked with every single vehicle, but that's not the case. So as you go through and work with your OEMs and figuring out which vehicle you want, please make sure you ask them, well, which chargers do you have in your testing lab? So which ones are certified with you for not just charging, but advanced load management and software, so that you're able to make sure that it's going to work when you show up and it gets on site. So having those chargers in the testing facilities of the OEM is critical, especially with when they do firmware updates or advanced load management, so you know that it's going to work when it shows up and gets installed. Let's go to the next slide. I think I covered most of this already in the last discussion around compatibility and what you need to do. So we'll go to the next slide. There is a whole series of things that we go through in interoperability. And testing this is a critical component to make sure that you have both firmware and there's a whole set of very technical things I'm not going to go through that are on the slides that you can review. But I'll give you an example. It's a critical component. Some vehicles, once you plug in most cases, you want your driver to pull the bus in, pick up the charging cord, plug it in, walk away, and have the system do everything else. In some environments, they start charging right away if it's not a higher cost or higher demand charges. In many cases, though, between 4 and 9, the utility sets a higher price or adds demand charges to charge the vehicle during that window. So our in-control fleet management software automatically delays the charging to the lowest cost period to charge. Now, to do that successfully, you need to make sure the vehicle will wake up after you plug it in. In some cases, the vehicle doesn't wake up. So working with the OEMs, we've been able to develop a workaround where they plug the vehicle in, trickle charge the vehicle to keep it awake for 3, 4, 5 hours, so that at 8 o'clock at night or 9 o'clock at night, there is a session already created, and we can then fully charge the vehicle in the evening when it's cheaper. But building that whole ability to keep the handshake is a critical piece that we test for and make sure we can do. And if we have to do a workaround, we're able to do it successfully. Let's go to the next slide. I'm going to show you a whole list of the things that we go through here. You can see them on their screen, but it's a pretty robust interoperability process to make sure that the charger works with their vehicle. I had a situation with a city recently where they had installed a number of level 2 chargers from a manufacturer, and they thought, oh, these work really well. They were unfortunately dumb chargers, and they thought we can just charge our bus with this as well. They got a couple school buses, and we'll just put in the same charging infrastructure because we know it. Well, the first day they went to charge it, it started charging for about 5 minutes, and it stopped, and they couldn't figure out why. So they called us up asking, hey, can you kind of help out here? We need some help. And literally when I got the call and I talked to him, I said, that charger's not going to work with that bus. And he goes, what are you talking about? And I said, well, that bus has 2 onboard converters. And so that charger starts charging on the first one. And when it switches over to the other one, it thinks there's a voltage drop and it shuts off for safety. I go, it's never going to charge more than 5 minutes. And they were like, wait, well, we didn't know this. So unfortunately, they had to rip out their brand new chargers, put in a different charger to make sure that it worked with that vehicle. But that's, I think, where experience and having a partner that knows which chargers work with which buses is critical. Going to the next one. So fleet management software, many times I talk with a school and they're like, why do I need this? What's the benefit of it? And it is a bit of a foreign concept because you're so used to be able to pull up the bus, fill it up with fuel, and walk away and you're done. Well, with electric vehicles, it's a bit different. You want to know, well, when is that vehicle going to be ready to charge? Am I charging at the lowest rate to lower my total fuel cost? If I have a problem with the charger, how do I get help? So all of these things are critical in having a fleet management software that can help you better manage your fleet, to lower the cost, to have higher uptime. And in many cases, if you have grants and incentives, or if you're reporting the CO2 offsets, you need a tool to provide all that information to you so that you're able to collect it and benefit from either the incentives or present that as part of your package for sustainability. So those are some of the key benefits that a fleet management software will do for you to make your job easier and to make it more effective in managing the fleet. Let's go to the next one. So you may have heard me talk a lot about lowering your total cost of powering your fleet. In the commercial world, the way you pay for electricity is 2 ways. One, you pay a cost for the amount of kilowatt hours you consume. And many utilities have a different cost depending on the time period. But you also have a demand charge. And a demand charge usually is the highest 15-minute interval during the month. And I've had school districts where this has added $15,000 to $20,000 to their electric bill by not by charging at the wrong time period. So what we do with our advanced load management functionality is we either delay the charging of the vehicle, so we move it later in the evening where it's lower, or we start balancing through dynamic power management and not hitting that peak demand. So we lower the total demand for the entire site, which then makes it a lot more cost effective to charge your vehicles and not pay those high demand charges. And we push it to charging later when it's less expensive. Or in some cases, some utilities have a midday, which is the lowest price point, and we maximize our charging during those windows. So I know this is a complicated topic, but one that we can go into a lot more detail if you're interested and explain how that works, as well as the ability to reduce a utility upgrade by using this. Let's go to the next one, which I think will really describe each three of the functions I just mentioned. One is by automatically power balancing between the vehicles and how much we charge on each one. So you may have certain vehicles that have to go out faster, or we're maybe doing this just to reduce the amount of demand or energy that you would be at the cost of that in different windows. The time shifting is pretty straightforward, I think, which is really just moving when you actually charge to off peak and lower cost regions. And the last one we've been able to really leverage, which is advanced site load management, where a utility may say, I mean, I'll give you a great example. We have Moreno Valley Unified School District in California, and their site has a maximum of 500 kilowatts of energy it can consume with both the buildings and the charger. Well, we were able to put over a megawatt of chargers on that site and be able to balance that where at any given time we'll never go over the 500 kilowatts. But as the building goes down in the evening, we're able to take more of that energy that's not going to the building and divert it to the chargers. So we're really maximizing that 500 kilowatt capacity over a 24-hour period to make sure they get all of their vehicles charged and didn't have to spend about $2 million in upgrading the utility and the infrastructure. Let's go to the next one. I think I've covered a lot of the smart load management and what you need to understand here, but it's really around how do you lower your demand charges? How do you reduce, charging during peak periods where they are very expensive to charge? How do you make sure that you are doing site load management so you're able to get the maximum amount of energy to the vehicles at the lowest cost? We'll go on to the next one. And that's really it for today.
Okay.
Love to answer a lot of questions. I threw a lot of technical stuff out there, so
Yeah,
hopefully
you
most of it, a
did,
lot
but
of made sense.
it was very informative, Steve. Thanks for that. And I am impressed with the number of questions we have. For the sake of time, let's just address two of them now, and then we'll wait to the end and address the rest of them. One is, do fleets need a garage to charge in cold weather? Do these things need to be inside to be charged?
No, they don't. We put a cold water package in there that will actually heat up the charger. I mean, it depends if the vehicle needs to be covered. It does help if you're in a warmer environment. It does use less energy and it does charge faster. But no, we have, I mean, I'm up in Toronto right now, and we've got a number of units distributed through northern Canada that are outside and are able to create, charging for those vehicles.
Good. Are there limitations on what kinds of charge management are available depending on whether level 2 or DC charging are used?
So that's a broad question. Their level 2 chargers typically only respond to a limited set of information. So you only have 6 data points to capture, one of which state of charge is not. There are some level 2 chargers that will allow you advanced communication protocols and give you the state of charge. The state of charge will allow you to then be able to do advanced load management because you know how much energy you have to provide back to the vehicle. The one workaround on that is if you have a telematics provider and you integrate the EV charging management software with the telematics, you can figure it out that way. But there are some challenges at times with certain level 2 chargers that don't provide you state of charge in doing advanced load management. There's no problem on the DC side because they have that enhanced information and we can capture state of charge.
Okay. I know on earlier modules, we did discuss V2G, vehicle to grid capabilities, and there are some questions here, but let's hold off on that and let's get to the last presentation and we'll address the rest of the questions after that, time permitting.
Great.
Okay. With that, I'll introduce Richie Beebe, who will discuss charging standards, maintenance, and safety. Rich.
Hello, everyone. Thank you for having me. So today we're going to be talking about charging standards, safety, and then at the end of the presentation, we're going to be getting into maintenance and best practices when a technician has to go out and work on this piece of equipment that are installed. And then I do want to say thank you to Steve and Brad for the first two portions of this presentation. Obviously, those guys are pretty smart at what they do, and so I'm just hoping to keep the bar where it's at. So looking forward to for this discussion, and then any questions or comments after the fact. So we can go to the next slide. So today the first three bullet points that we're going to be looking at is going to be kind of an overview of what Brad spoke about in his discussion. We're going to be talking about the different types of electric vehicles and their charge port designs, describe the differences in levels of EV charging, identify the primary types of chargers, and also touching on the adapters, which as an industry right now, there's, everybody's still trying to figure out what the standard is, let's say. So having an adapter for charging is useful and beneficial for drivers as they're traveling, especially in long distances. And then really, the last portion of this presentation is going to be really focused on the personal protective equipment, or PPE, for performing work on high voltage, and also just identifying any hazards out there when working on a piece of equipment. We do have AC voltage out there, and then we also have the potential of DC voltage too for the level 3 DC fast chargers. Then we're going to look through the lockout tagout practices and the equipment necessary for lockout tagout. And then we'll be getting into the different types of EV tools, or tools to work on some EV equipment out there. And again, it's more broad, but and I will highlight some of the specialized tools that we would need for our technicians when we go out to a site to try to work on a EV charger that's offline or not in use, or there's no power going to the piece of equipment. And then lastly, we're going to talk about best practices for charger and equipment maintenance. We'll get into some of the OEMs and the certification requirements in order to work on those pieces of equipment, and really understanding, how to put your best foot forward when we show up to a job site and start working on a piece of equipment. And then in regards to the certification too, we're also going to talk about warranties as well. So, having an understanding that you're capable and able to work on a piece of equipment before you start tearing into it, which could potentially avoid a warranty through the original equipment manufacturer. So you can go to the next slide. All right, so next section, we're going to be talking about the different types of EV ports, the designs, levels of charging, and then the adapters. You can go ahead. So the different types of electric vehicles out there right now. I like to always talk about this because even though it's hybrids and plug-in hybrids have been out there for quite some time now, and then full, EV vehicles, I still want to touch base with it, just because when somebody says hybrid, they typically go to what we know, like a Toyota Prius, which has been out in the market for quite some time now. There's an internal combustion engine, there's an onboard electric motor that the internal combustion engine uses to power to charge that battery in order to use. And then once we get into a plug-in hybrid EV, it basically spells it out there in itself. You can still charge at a level 2 capacity, some instances a level 3 capacity DC chargers, but primarily it's going to be an AC charger that is what's going to power the, give AC current into the battery management system, which will then charge the battery. And then we do have the fully electric battery electric vehicle, which does not have an internal combustion engine. It only has a battery pack that powers the electric motor. Go to the next slide, please. So this is electric vehicle supply equipment. So just wanted to talk about some of the terminology that we could hear out in the industry right now. But the EVSC is what would supply an electric vehicle with current, AC or DC current. So some of the various terms that we see out there is charge points, electric recharging points, and then charging stations. So they ultimately do the same thing with the battery electric vehicle and the plug-in hybrid electric vehicle. They're sending current or voltage into the car to charge the battery in order to propel the car. And then we're also going to talk about the different various charging levels. So level 1, level 2, and level 3. So you can go to the next slide, please. So we are going to talk about, this is how the EVSE charges an onboard battery. So a level 2 and a level 1 type charger supplies AC voltage to the battery management system or the onboard charger, which then rectifies the AC to DC and then supplies the battery with DC voltage. A level 3 DC fast charger takes an AC voltage coming from the utility and then rectifying it to DC in the charger itself, and then it supplies the EV with DC voltage directly to the battery. Go to the next slide. This is just talking about voltages from the AC and DC. So a DC fast charger, typically what we'll see out there in the field right now, it's 480 volt, 3-phase from utility power. In some instances, it could be a 208 volt, 3-phase from utility, but standard, typically what we'll see out there is the 480 volts. And then an AC charging station could be single phase from 120 to 208 or 240 volts. And that's what you would see, in a home, obviously, for 120 volts to 240 volts, and then level 2 AC charging. For certain fleet applications or customers, they would have the 208 single phase. Go to the next slide, please. So getting into level 1 charging, this is just a typical standard 120 volt wall outlet that you would see at your home, in your garage. And a lot of these, this type of charging is beneficial for certain customers or drivers. If they're not driving long distances, if they're going to and from work, if it's a round trip, 30 to 40 miles, they're not taking long road trips, this is sufficient enough for them. They plug in, they can get 3 to 5 miles per hour of charge. And like I said, that's just a regular 15 amp circuit or a 20 amp circuit. Typical garage circuits are around 20 amps, so you'll be getting the 1.9 kW of charging. And that's sufficient enough for them. A round trip would drain their battery, let's say 20, 25, 30%. But then, charging it overnight, you would only need it, to get up to another 30 to 40 miles, and that's sufficient enough for them. You can go to the next slide. So level 2 charging, you'll see this, you could see it at residential facilities. It is a little bit faster of a charge. You can get anywhere from 12 amps to 80 amps. But typically what we see is a 32 amp load on these units. And that's due to the battery management system on the EV vehicle. It can only handle up to, I think right now, some of the vehicles out there are 11.1 kW is what we see. So, understanding what the vehicle can accept and then what the charger can output, that's definitely key, because even if you bought an 80 amp charger, spend a little bit extra money on that charger, your vehicle most likely won't be able to accept that charge rate. And then I do want to talk about the charge ports, which I'll get into more detail, but J1772, it's an AC, and then the NACS or the Tesla charging. NACS is the let's say standard right now is what Tesla has, and that can provide AC voltage to the EV vehicle. Go to the next slide, please. So EV charging, the level 3 or DC fast charging. Like I said earlier, this is typically 480 volts, 3-phase. It can be anywhere from 50 amps all the way up to 400 amps. And, as this progresses, we could see even larger currents going to these chargers. There are 3 different types of ports right now for the vehicles. Standard is going to be the CCS1 or the J1772 combo is what they call, which that's the center charging port up in the top, charging port on the top right corner. We have the Tesla supercharger. Like I said, that could be AC or DC. And then I did want to touch base on the CHAdeMO cable. So the CHAdeMO is typically seen in the Nissan Leafs and some of the Mitsubishi vehicles out there. We're starting to slowly see that phase out. Everybody's going towards the CCS combo or the CCS1 or the NACS cable. But there still are requirements in certain areas from government-funded projects that do require the CHAdeMO port, at least on one of the electric vehicle charging stations on certain at certain facilities. You can go to the next slide, please. And then just to give a little more detail on the level 1 and level 2 for the AC, you have on the J1772, you have the line 1 and line 2. Your 2 smaller ports to the left and the right is a proximity detection and the control pilot, and then the equipment ground on the bottom. So the one thing to point out in this is the equipment ground is the portion of that connector that makes the first connection point, and then it's also the last connection point to be broken when you take that charging cable out of the vehicle. So you're always grounding it first, and then that's the last to leave to prevent any sort of arcing, or if any arcing does occur, the equipment ground is there for protection. Go to the next slide. The level 3 DC fast charger connector, very similar to the J1772. It has the same ports, L1, L2 up top, control pilot and proximity, and then the earth ground or protective earth ground. And then this one does have the DC negative and DC positive at the bottom. So the L1 and L2 up top, it's not utilized for this cable, but in the port design on the EV vehicles, like I said, it can accept the J1772, or as long as it's capable of accepting the DC voltage, it would have the DC negative and positive ports. Go to the next slide. Similar to the NACS, similar to the CCS1, you have your line voltage or DC voltage on the top left and right. You have your communication ports and then your ground port for the NACS, North American Charging Standard Cable, or Tesla Supercharger connector. Go to the next slide, please.
Rich, you have 5 minutes.
Okay. The adapters are pretty important here because, like I said, not everybody knows, from what I've seen, not everybody knows what is, they see an EV charger, they have a Tesla, they go up to it, or, Mustang Mach-E or whatever, they go up to it, and then they realize it's a CHAdeMO port, it's a NACS port, it's a CCS port, and they're, kind of stuck there thinking like they'd be able to charge. I've seen that numerous times with customers. They'll install a CCS charger, they'll pull up it, with their Tesla, realize that they can't charge. So having these adapters available for consumers is it's a benefit, so that they'll be able to use multiple different charging ports for their vehicles. Go to the next slide, please. All right, we'll get into the safety precautions, PPE, lockout, tagout, and then the EV tools. Go to the next slide. So this is going to be the personal protective equipment when working on live voltage or verifying the absence of voltage. So coveralls, which coveralls can range from an 8 cal all the way up to a 40 cal, which are, let's say, those big moon suits that you see people in when they're testing live voltage, like linemen. Dielectric hard hat with arc flash shield for face protection, balaclava, which is it's neck protection, safety glasses, earplugs, and then the protective rubber gloves with a leather overtop to protect the leather from punctures or scrapes or yeah. So you can go to the next slide. So getting into performing lockout tagout is we want to establish an electrical safe work condition. So that's preventing any unexpected energization or startup of machinery and equipment. It's designed to shut down the equipment, to control all energy sources, render the machine in the safest state possible in order to work on. And then we want to document these and then evaluate once the ESWC has been completed. Go to the next slide. So lockout tagout should be applied by an authorized person working on the equipment. We should always be applying your own lock when working on a piece of equipment. It should always be tagged with the information from the person that applied the lock. And then we do not want to remove anyone else's lock because we're not aware of why or the reasoning behind that lockout tagout, why it was applied. You can go to the next slide. And then the tools needed for lockout tagout, touched base on this just a second ago, but the locks, any sort of hardware tags so that you can tag it appropriately, and then a device that would lock out. It could be a breaker, it could be a valve, pretty much anything that would prevent a energy source from being opened to cause harm or bodily damage. You can go to the next slide, please. And then last thing before we move on to EV tools is having a fire extinguisher. So typical technicians in my organization, we have an ABC, which pretty much handles everything that we would be working on. In this instance, electrical equipment is sufficient enough for what we do. And then in certain scenarios, depending on the facility, you could see a Class D fire extinguisher. And you can go to the next slide, please. Best practices for fire extinguishers. Obviously, the most important thing is everyone's safety. So if you're able to put out a fire, you can go ahead if you have the proper training and proper fire extinguisher to extinguish the fire. You want to back away. And then if you're unable to put out that fire, you always want to call 911. I'm sure we've all seen it in the news when an EV goes up in flames. There's really not much we can do with it. Even the fire departments basically say that they have to just let it burn until it stops. Next slide, please. And I know I'm running up on time, so I'll be a little bit quick on the tools. So PPE and lockout, that's what we've talked on. Cell reader is what we would, verifying that the communication is there. Cellular network is typically how these units talk to the cloud or their server. So having that to verify that the cell service is good. And then an AC and DC multimeter, obviously important for when we do our lockout, tagout, and then testing out. You go to the next slide. And then, so this is charger maintenance, best practices, and overview. Go to the next slide, please. Best practice for working on a piece of EV equipment is being prepared for the work at hand. Understanding what the OEM requires, having the proper tools, the PPE, having the lockout, tagout equipment, and ultimately assessing what the issue is when we show up to a site. So, it could be anywhere from power outage to a corrective maintenance, really understanding what needs to be done and having all the tools and equipment and the knowledge. That's going to set our technicians up for success to, repair the unit, get the unit back up online, and then prevent any return trips going back to that site. So first time fixes is what we're going for. Go to the next slide, please. Different types of maintenance. Commissioning. Over the past couple of years, we've really seen an uptick in commissioning, and that's due to more complicated installations, especially when it comes to DC fast chargers or level 3s. So what we do is verifying that the installation was done properly according to the manufacturer specification. We also verify that the electrical infrastructure was done correctly, so that when the unit is powered on, it's getting the correct voltage, it has the correct overcurrent protection device on it to protect the equipment and protect the wiring. And then really it's ultimately about the manufacturer's warranty too. So if the installer performed the installation wrong, could damage the equipment, which then could void the warranty. Preventative maintenance is also important, and it's based off of the OEM and what they require. Typically, they're going to be annually, but there are some manufacturers out there that require quarterly or monthly preventative maintenance, and that could be coolant top-offs, filter replacements or cleaning, and then really visual checks, verify that the cable isn't frayed, the connector's working as it should, the HMI, the human machine interface screen, is visible, and if it's a touch screen or if there's hard keys, that those are working properly. And then in certain scenarios, checking the torque settings on AC and DC voltage or AC and DC wiring coming in and out of the unit. Go to the last slide. And this couple other ones is break fix or corrective maintenance. And this could be anywhere from wear and tear, vandalism, the cable management on level 2 and level 3. It's a mechanical component that could break or wear down over time, a lot of pushing and pulling from the driver. And then, as I said before, the human machine interface. And then we do see a lot of maintenance dispatches that would be because of a charger being offline, cellular connection isn't working, or there was an issue with the electrical infrastructure, maybe a power outage, or a main switch gear loses a leg. So verifying that the voltage is correct on what the manufacturer requires. And again, this is all recommended type of maintenance, recommended type of commissioning and preventative maintenance. And as we perform this type of work, obviously following standard safety procedures is key. Being familiar with the product, having the right certification is key as well. And last thing that I want to say on this topic is, if you don't feel comfortable performing any of that type of work on the equipment, then just don't do it. Because again, it's all about everybody's safety, making sure everybody returns home safe to their families. So I believe that was the last slide.
Yeah, that's it. Thanks, Richie, for that. We do have a good number of questions. We might go over a little. What we don't get to, we will address separately and send out to you. But Rich, let's answer this question. Could you please review recommendations for electric vehicle infrastructure training program electricians and what type of extra training they may get for e-bus charging and design work?
Yeah, so the EVITP is what you're referencing. That is it's a requirement in certain areas that it's a certification for electricians in certain areas that they have to take. There's a 20-hour course online that they have to go through, and then they take a final exam, a proctored exam, to get that certification. And what we've seen, usually it's because it's a NEVI funded site, and then that site requires to have EVITP trained electricians on site during the installation and also service and maintenance.
Okay. If I could ask Steve and Brad to put your video back on and unmute yourself, and we'll get to the rest of the questions and see who's best to answer it. One concern we have heard is that bus batteries will wear more quickly if they're only charging off of DC power versus using AC power or a mix of AC and DC. Is there any validity to this concern?
Yeah, I'll take that on from the vehicle side. Certainly DC fast charging, it puts more energy in quickly, right? But over time, and especially with electric vehicles in the retail environment in the past decade or so, it's not nearly as significant of a degrade we use in DC fast charge versus AC charging. So if you're obviously charging the vehicle. In the case of our the bus side, we're not going up to 350 kilowatt or 180 kilowatt or even 120. So our DC fast charge levels are even supportive of whether you're AC or DC fast charge. The battery integrity should remain fairly similar between the two over the life of the bus.
Okay, what are the typical life in years or total vehicle miles traveled for school buses? How how often uh, how often do they have to turn over to new vehicles?
Yeah, so that's another great question on the vehicle side. School bus is a very unique case in the fact that they often put more hours of operation in than they do odometer miles. Typical service life is 7 to 15 years, but it's not uncommon to find a school bus that's 15, 20, sometimes even 25 years that's still in service. But odometers, in the 60,000 to 200,000 miles of odometer range in that time frame is pretty common. So not 2 million mile vehicles, but certainly accumulating a lot less miles. The warranties on these vehicles and batteries are really predicated around hours, the number of charge cycles, often the what's called gross discharge, or the amount of energy going in and out if they're using V2X capability. So you're well covered in that particular sense. But that's kind of the typical on the school bus environment for life cycle. Usually 7 to 15, and again 60 to 200,000 odometer miles aren't common.
Will the batteries last the entire time?
While the battery warranties are certainly centered around the 8 years, and in our case 8 year 125,000 miles in the U.S. It's anticipated that 10 to 12 year life of that battery without any real maintenance or service should be typical. If it gets to the point where you start using or losing enough usable capacity, then you may want to consider battery maintenance or replacing the modules and or cells in the battery that need to be replaced. Doesn't necessarily necessitate a whole entire battery replacement.
Okay. In our last modules, we discussed vehicle to grid capabilities, V2G. Could someone just briefly describe what that is and the benefits of it?
Yeah, you want me to tackle the V2G?
Yeah,
I can do
yeah.
that.
Go ahead.
Yeah, I think it really does vary depending upon if your local utility will pay for the electricity going back to the grid or to the building. So that's one thing you want to understand is there a benefit that you can monetize? We do see many utilities that will allow the ability to do arbitrage, and that's where I charge at evening when it's inexpensive, and then I dispatch energy during the day to the building when prices are expensive. And you're really offsetting load from the facility building. Um, I can give you some numbers roughly for if you did that in the summertime when the buses were idle and there was a 10% spread between on peak and off peak energy, it generates about $3,000 per school bus for the summer months to be able to do that. Part of your calculation in that is to understand what is the impact on the life of the battery and the benefit that you have. The other area we're starting to see more of this is using V2G to power a building in order to, if it happens to be a disaster recovery or if the grid goes down, can you power a facility using the batteries in the vehicle? I think that's a little bit more bleeding edge, but we're starting to see some technologies there. So I think it really does depend on Your local utility, are you allowed to do it? The amount of money you're able to monetize by doing V2G, and then some of the other ancillary benefits. So hopefully that helps answer the question.
Yeah, does it make sense to acquire and install all this equipment at once, or could you buy the bus and add the other bidirectional equipment later?
It depends on what you're trying to do. If you're truly trying to do V2G where you're pushing energy back to the grid, you need to install a whole additional set of equipment and switchgear to decouple from the grid, so that if the grid goes down, you're able to either power back the building and manage it that way. We do see a number of schools that are installing V2G chargers, which are about a 20 to 30% increase in the cost to future-proof their installations and use that later, especially where they have line of sight to some utility programs that they can benefit from.
Okay. Well, I was just got word that we need to wrap this up now, but we will address the remaining questions and send them out separately. Ryan?
Yep. Thanks everybody for hanging on for a couple extra minutes. Thanks to the presenters. Really great info, guys. Really thanks a lot. Thanks to all the presenters from previous modules. And John, thanks a lot to you and your team. You guys did awesome throughout this whole process. And everybody who had questions, we'll get back to you. cleanschoolbus.ta@nrel.gov if you got follow-up questions. But again, thanks a lot for joining and hanging in there.
Okay. Thank you all. Bye-bye.